Hello, Professor Fleming. How are you?
Hello, it's on. Very well. Good to see you.
Nice to see you again.
I want to ask you one quick question right off the bat. How do I pronounce your first name? Is it Asan or Ashan?
The former
Okay,
Esan. Yeah,
very
you
good.
got it. Yeah, thank you. How's
So,
your day going? All right.
yeah, very well. And you, what's the weather like? Are you anywhere close to any of the bushfires in Australia?
Not really close. The bushfires are now under control. We've had a few floods over the past few weeks,
Oh, yeah,
and the
right.
weather's really nice now. It's about 25 degrees Celsius, which is
Uh-huh.
I don't know what that is in Fahrenheit, but yeah.
Yeah, all right. Okay, good.
But yeah, it's quite pleasant.
Very good.
And it must be still cold over there. Is that right?
Yeah, it's cold. We have a few warm days coming up, which I'm looking forward to, but I sure wish spring would arrive and I could get back on my bicycle.
Oh, that would be wonderful. Yeah.
Yeah,
Well, thanks so much for making time today. I've really appreciate it.
my pleasure.
And I'm glad we connected just before I left.
Yeah.
Yeah.
That was very nice.
So
So, what kind of questions do you want to ask?
I guess I had a few different questions about mainly time and parallel universes and quantum mechanics, a few different
Uh-huh.
things that has been on my mind, and I do apologize. Some of these questions may seem kind of it might seem trivial or lame because I've been out of the physics kind of game for quite a
I
while.
the,
So,
the questions will be fine. Yeah, so go ahead.
so if, one of the a few things that I've been kind of thinking about in terms of thinking about the observer, like how we observe light and how something happened, and I guess it's good for me to give you the background of when it all started. It happened in November. I went on a 10-day retreat in the Blue Mountains, which is about 100 kilometers here and I was just spending walking around in nature, and I saw butterflies kind of flapping around and kind of interacting with each other. The two butterflies, and they interacted with each other within about 2 seconds. They had done something we would do in about 2 weeks, right? So bear with me when when I'm kind of going
Yeah,
through this experience. And I realized they would experience time very differently to us, and so at the time I didn't have time. Well, I didn't have access to technology, but when I came back and I did a bit of research, and I realized insects see things in slow motion, like they uh, compared
right.
to humans, and so time is perceived differently to smaller animals, and it seems the reverse is true. Like for instance, a turtle, a sea turtle, would see time faster than a human being, so they would see things flying by much more quickly. And of course, that has to do with biological factors, so the
Right,
metabolism,
right.
metabolic rate, and things like that. So it might not seem completely relevant to physics, but I'm thinking that my personal belief is everything's interconnected. Like how
Mhm.
biology works fundamentally would be mirroring the physical world in some way.
Right, right.
And also so I kind of so that was where it all started, from that experience, and I started kind of bringing consciousness to everything, to even like to physical particles, like even electrons and
Uh-huh.
photons and so on, and seeing things from the perspective of these particles, like if they had consciousness. And this may sound silly, but um, how light would perceive its environment in terms of the observer.
Right.
So for instance, let's say that we're looking at the one of the famous experiments, the double split experiment. So we have an observer observing a photon or an electron or a tiny particle, and the nature of the particle changes in terms of whether it acts as a wave or a particle.
Hmm.
So, so the observer and the observed have a different time frame. So almost would it be true to say that the static observer is pretty much looking into the past, and the moving observer, the electron or the photon, is looking into the future? So they actually slightly have different time frames, and this is just this is a I'm just thinking out loud, and
Right, right.
and so when the particle decides to act as a particle or a wave, it's because it knows that, I mean, the observer is looking into the past, and the particle is looking into the future. So it's almost like when it knows that it's been observed, it knows where it's going. So that's
Well,
kind of,
let me ask the following.
yeah.
When you make this distinction between what you refer to as the static observer viewing in the past and the moving particle viewing into the future, first of all, I don't really know what you mean by this difference between viewing in the past and viewing in the future. But even if that gets cleared up,
Mm.
especially in relativity theory, we very much emphasize the idea that all motion is relative.
Mm-hmm.
So while if I'm moving without acceleration, just with constant velocity, and I can be oblivious to the fact that I'm moving, so I seem relative to myself to be static,
Mm.
but I'm moving relative to some other system, some other observer, some other particle. So if these two observers and particles that you're referring to, they have a relative motion, and the
Correct.
motion of the observer relative to the particle is equal and opposite to the motion of the particle relative to the observer.
Mm-hmm.
So given that fact that there is no absolute status to the motion of either one of them, there's only relative motion between them, then I'm puzzled as to this distinction between one observing in the past and the other observing in the future. Can you elaborate on that?
No, absolutely. I think that's it. That definitely is the case. Now, if so, we're looking at relative motion, right? So I guess
Right.
this. So when so there is no static observer. Essentially, there is no static observer. But if you're looking at the observer and the observed, and if the observed is moving close to the speed of light, in relation to the observer, then that's kind of the scenario we kind of looking at.
Okay.
Yeah. Would that kind of clarify the scenario, or?
Well, for instance, there is this kind of looking into the past. When astronomers in particular look at very distant galaxies,
Mm-hmm.
we are seeing them, in a manner of speaking, as they were long ago,
Correct.
because it takes so long for the light to reach us.
Mm-hmm.
But if a particle moving close to the speed of light were in any sense able to observe, it presumably would be subject to the same limitation that our astronomers are subject to. If they observed light from a distant galaxy, they would be observing the galaxy as it was long ago,
Mm-hmm.
not as it is when they're observing.
Correct.
So the whole concept of distant time ordering and distance simultaneity, that's where all the relativity aspects of relativity theory really come into play in a strong sense. The greater the spatial separation between an observer and a phenomena, or an observer and an event, the more radically different the assessment of time becomes in relativity theory compared to pre-relativistic thinking, where in pre-relativistic thinking it was assumed that simultaneity is the same for everyone, no matter what your state of motion is. If two separate things are simultaneous, they're simultaneous for everyone. But in relativity theory, that's no longer the case, and that complicates considerably the assessment of time intervals. But in what sense would you mean that some observer, some particle, was viewing into the future? In what sense do you think any observation into the future is possible.
And that's something. It's not making logical sense. I think what generally happen is so so if you're looking at let's look at the first example. If you look at a very tiny creature looking at us,
Mm-hmm.
their perception of time is extremely slow. So as we move, they see us moving very slowly, and I'm thinking whether that has anything. So I think then I kind of took that assumption and I made that infinitesimally small,
Right.
so that it kind of, let's say it's an electron or it's a photon,
Mm-hmm.
and a photon kind of having consciousness and observing its environment. How would it see its environment? Like if it's so if a
Okay.
particle, yeah,
Let me
sorry.
respond to that a little bit.
Hmm.
I'll balk a little bit at attributing consciousness to photons, but I'm not so troubled by attributing consciousness to birds or other living organisms. So let's suppose that's the case.
Yes.
I think I would want to make an important distinction between the experience of time, which for us and presumably for other living organisms as well, can vary quite a lot depending on the circumstances they're in.
Hmm.
I remember once years and years, decades ago, when I was riding dirt bikes, and I went up a hill too fast, and my dirt bike went over, and it was above me, and I was below it, and I was looking at the sky, and it was one of those situations where it was a dangerous situation, and my brain started to race. And as a consequence of my brain racing, it seemed to me that time was slowed.
Mm.
I don't believe for a minute the time was slowed. It was just my brain racing. So my experience of time was quite different.
Hmm.
So I would want to draw a pretty strong distinction between the experience of time and the measurement of time.
Got it. Yes.
And measurement of time is something that can be done even in the context of relativity theory, where different observers make different judgments about the time ordering of certain events or the time interval that separates certain pairs of events. Nevertheless, the methods of measurement are pretty rigidly stipulated, and if all observers follow them, it doesn't mean they will agree on their measurements, but they will disagree in a way which is quite compatible with the principles of the theory.
Got it.
So this doesn't interfere at all with the fact that the way we experience time can vary dramatically depending upon the circumstances that we're in. But that's a consequence of the firing of neurons, the change in our metabolism, sensory deprivation or sensory sensitization, all kinds of things like that. So just wanted to.
No, I think that. Thank you for that. No, that makes that. That's definitely the case. I can understand that it's the experience that. So the measuring the measurement of time is more absolute. No, will not quite absolute, but it
more objective.
More objective. Correct.
Yeah.
So I'm just trying to make sense of the double slit experiment, I guess.
Okay. All right.
And
so are a lot of other people.
Yeah, absolutely.
There is, by the way, let me mention that there is this big difference between the reaction of both physicists and philosophers of science to relativity theory and the reaction of physicists and philosophers of science to quantum theory. Relativity theory has many counterintuitive, hard to wrap your head around features, but everybody agrees pretty much with what those features are, what the problems are, and at this stage of the game, everybody agrees pretty much on how to resolve the apparent counterintuitive features and make them almost intuitive. Quantum mechanics is a whole different ballgame. There is almost no agreement. There is a large group of people who follow the admonition to just shut up and calculate. Don't worry about these counterintuitive issues. But among the people who worry about the counterintuitive issues, there's no agreement, almost no agreement whatsoever. There are the Copenhagen interpretation people. There are the Bohm pilot wave people. There are the many worlds people. There are the spontaneous state reduction people. There are the gravitational state reduction people. And they all conflict with one another in the way they try to understand quantum mechanics. It's a real mess.
Yeah.
And yet all of these people know how to use quantum mechanics. And everybody agrees on how you use it. But nobody agrees, almost nobody, no two people agree on what it means, on what the deeper interpretation is. And so there's a tremendous amount of work going on in that, and has been for a long time.
Yeah. So then I guess, is there from your perspective, do you have a favorite kind of theory that
on quantum mechanics?
Yeah, of quantum mechanics.
Yeah, I do. I do have a favorite one, but by no means do I regard it as settled that my favorite is the correct one. But nevertheless, I will tell you what my favorite is. And my favorite is what is called spontaneous state reduction. Namely, that the state reductions that the originators of quantum mechanics talked about, which they only talked about state reduction when you made measurements. And this state reduction is on one hand very important. On the other hand, many people hate it, and they'll do almost anything to get rid of it. I think it's very important, but I think it cannot be, as many do, I think it cannot be restricted to just human beings with PhDs making measurements in laboratories. Because that sort of undoes the Copernican revolution. It puts us back in the center of being, the center of all existence, the most important thing. So the spontaneous reduction argument is that state reduction is going on all the time, spontaneously and randomly. Very, very rarely for any given fundamental particle, like an electron, or a photon, or a quark. Those individual entities get hit by state reductions very rarely. But if you're talking about like a coffee cup, a macroscopic object made of gazillions of these fundamental particles, the fact that one or another of those particles is getting hit by a spontaneous state reduction all the time, and those spontaneous state reductions on a single particle in the solid object pull the whole solid object along with it, so that the solid macroscopic object is being zapped by state reductions very rapidly all the time. And that's why those solid macroscopic objects look so classical to us. Now, I don't mean to suggest that all the details of this argument have been worked out satisfactorily. They have not. But this is the general idea. And I favor that particular approach. I think that's the one that makes the most sense to me. But there are many people working in the field who just despise this whole idea of state reduction. And they try to formulate quantum mechanics without any state reduction at all, even state reduction when we make measurements. And that just makes no sense to me. So that's my favorite. But.
And in terms of what causes the state reduction, because generally for state reduction to take place, do we need an observer? Do we need something?
The answer is to that last question is no. None of the formulations that have been put forward concerning fundamental state reductions, none of them require an observer. But there is one big difference between the two versions of state reductions. The one version just has the state reductions as spontaneous, random things. All you can say about them is what are they like when they occur, and how rapidly do they occur for any given fundamental particle, electron, photon, what have you. But they provide no explanation of what causes them. The primordial state reductions are essentially uncaused events, things that have no cause and perfectly random. There's another version in which, while the state reductions, the fundamental state reductions, are still perfectly random, they do have a cause. And the cause is a situation in which the gravitational energy associated with a superposition of two different states, if the gravitational energy associated with the one term in the superposition is sufficiently different from the gravitational energy associated with the other term in the superposition, then that will spontaneously produce a state reduction that will favor the one term or the other term. And that version of spontaneous state reduction is pushed by Roger Penrose, a name you might have heard, very famous physicist and mathematician, and other people. The perfectly random spontaneous state reduction that has no cause whatsoever is associated with the names of Gherardi, Ramini, and Weber, usually referred to as the GRW theory. But neither of these schemes, even though they've been worked on for a good while now, the GRW scheme started in the mid-'80s, like 1986. People have been working on it ever since. And they still haven't got it to the point where it's a completely satisfactory way of explaining state reductions, if you happen to believe that state reductions take place.
Mm-hmm.
So.
And with so the state reduction theory is different to the many worlds or parallel universe theory. Is that right? That's kind of
yes, dramatically different. Here's a way of characterizing them. In the state reduction case, even the original Copenhagen theory, which had state reduction restricted to just the result of human measurements. Mm-hmm. You make a measurement, quantum mechanics tells you there are maybe 100 different possible results to your measurement, and quantum mechanics will give you the probabilities associated with each of those possible results. You make a measurement, you get one result or the other. Mm-hmm. You make the same measurement again on the same kind of state of the system, you get another result or another result. The many worlds people say, no, you didn't get a result in your universe. Rather, your world split into 100 different worlds. And in each of those worlds, one of those results occurred. But there is a world that comes into existence every time you make a measurement for each of the possible results of the measurement. Now, try to wrap your head around the idea that this has been happening, presumably, for, that we're told that since the Big Bang, the universe has aged by about 13.8 billion years. And it's not just measurements that can induce this splitting. Other things can induce the splitting also. So the splitting's been going on ever since the Big Bang. That's a lot of worlds.
That's a lot of worlds. Because it's like it's almost if it does happen, it's happening not like every second. If it's like it's a very small. It's
right.
It's
right. Exactly times, right.
Yeah.
Yes. And the thing is, at least in some of the more strident versions of this idea, it's impossible for any of these worlds to have any interaction with one another. So there's nothing you can do in your world to find evidence of the existence of the other worlds. Mm-hmm. Now, to the extent that that's the champion of many worlds is doctrinaire about that, to me, that removes many worlds from the realm of science altogether, and it just becomes the realm of wild speculation because you can't do anything to test it. There's no prediction you can make and then go to the laboratory or go anywhere else to see if the prediction holds. So I'm very much opposed to that.
Mm-hmm.
But I won't go so far as to say that it's impossible that that scheme could be right. Maybe it is right. It's just so antagonistic to my internal psychology that I can't embrace it.
And Professor Fleming, what about the nature of consciousness? What do you think about consciousness? Is that something that, and that's kind of another thing that's really kind of been bothering me, is like, where does consciousness come from? Like, for us to be conscious.
And that is, right now, that is very much a growing topic of serious study. I mean, philosophers have been interested in that kind of question for ages, but more and more scientists, neuroscientists, artificial intelligence people, biophysics people have been getting more and more interested in analyzing the concept of consciousness and the breadth of phenomena associated with consciousness. I have a mild preference for certain kinds of ideas, but by no means am I an expert in that field. So my ideas they're very tentative. I tend to think of consciousness as a kind of emergent epiphenomena. Mm-hmm. I'm very skeptical of the idea of free will, mm-hmm. and I'm very impressed by what the neurophysiologists frequently tell us, that they have evidence that when we think we have made a decision, there is neurophysiological evidence that our brains, in effect, made the decision before we become aware of it.
Correct, yes.
And, oh, really?
That's right. I think
Why
something like
didn't let me know sooner?
Like 6 seconds or 30 seconds, something like that. I think.
Yeah, sometimes it's quite dramatic, the time difference. Mm-hmm. So that makes me think of consciousness as an emergent epiphenomenon. Now, when did it emerge? I don't know. Maybe some pre-human hominid, Peking man or Homo habilis or something, were they conscious? I'm inclined to think they were, but how far do we have to go back in evolution before we find a biological organism that isn't conscious? Is an amoeba conscious? Is a paramecium conscious? I'm a little skeptical, but I would never say that I know one way or the other. It's a possibility. Mm-hmm. So I'm delighted that I'm conscious. How dull life would be if I weren't conscious. But of course, if life were like that, I wouldn't know that I was unconscious.
Yeah, no, absolutely. No, I think it's just, for me, I'm trying to wrap my head around all this as well. And the fact that, I mean, it could have been a complete random process that has led us to where we are today. And yes, I guess but it's just interesting how we've got to this level. It's just pretty phenomenal.
I agree. And I tend to champion the idea because from my perspective, I think that one of the most important things that we discovered with the discovery of quantum mechanics, which is now, we're closing in on 100 years since we discovered quantum mechanics. But I think among the discoveries, the most important part is the discovery that certain things just happen and they don't have causes, they don't have reasons. So that goes a little bit beyond just indeterminacy. Where indeterminacy just means everything is governed by probabilities, but you have causes for things even though you don't have determinism. I think there are certain things, like for instance, the radioactive decay of a neutron. On average, that takes place about 15 minutes after you get your neutron. But when any given neutron spontaneously decays into a proton, electron, and antineutrino, there's no way of accounting for that. And quantum mechanics gives us a probability distribution for the way the probability for the neutron surviving past a certain longer and longer times just perfectly. So I'm inclined to think that when the neutron decays is totally random. Nothing determines that. A lot of people have a lot of difficulty with that idea, but it seems to me the best way to understand certain aspects of quantum mechanics.
Mm.
Now, do you read various books on like relativity theory or quantum mechanics in order to make some progress with your thinking on these matters?
Well, I used to do that long time ago, and the nature of my job doesn't really kind of allow me to spend a lot of time. Like I've got many roles and wear many hats at university, many of which are very administrative and it's teaching and research in leadership development primarily.
What do you teach? What do you do research in?
So at the moment, I'm teaching a subject called Building a Sustainable World, which is around sustainability, and it's a project-based unit. So a lot of my teaching is around how to manage teamwork and leadership of self, leadership of others, leadership of change. So it's very macroscopic, and but one of the things one of the things I really am passionate about is be able to and it sounds overambitious, but I just want to be able to give a foundation to my students so that they get an understanding of how everything works, like from a microscopic perspective, but also a macroscopic, whether it's from how nature works and how humans work, how we make decisions, how we, from human behavior to the atomic level. So just giving them a kind of a foundation.
Right.
And I think that's really important because I think a lot of us, students, and that's how education just goes, everything's so fragmented and there's no overview of how everything works holistically. And I think if they want to be better leaders, they should have a better understanding of how the world works. From the atomic level to the human behavior level and nature. So that is
that's certainly a very worthwhile and important effort to make, and I can well imagine the difficulty of fitting it all into the schedule for what you have to teach the students.
Yeah, absolutely, and it's like
more
13 weeks.
Right?
So it's 13 weeks, and I just want to kind of start with the nature of physical reality and how we're, at the fabric of reality as we mostly space, and it's to forces and attractors. Like one of the work I'm trying to do is try to explain human behavior using very raw physical phenomenon, which is like the fact that how we make decisions, like how can be linked back to how nature works, like in terms of physical phenomena, right? And biology, and just linking all of this. So linking pretty much psychology to physics, and so if you have any kind of guidance for me, like to what I should look at, if there are any really good books or resources out there. That's one of the things I'd like to do, is be able to explain everything from a very holistic perspective.
Okay, yeah, I would certainly be willing to think about that. Now, the one difficulty would be I don't know what you've already read, and what you might have already suggested to your students. But I guess it doesn't matter too much if I overlap a bit.
No, absolutely, not at all. Yeah.
Yeah. Yeah, I'd be willing to. I won't try to do anything right off the top of my head right now
Sure.
because that would be a incoherent mess.
Mhm.
But I'll give it some thought. Um, yeah.
I appreciate that.
Okay.
I think one of the things that really I find interesting, and it's almost like um, the nature of everything we see around us, and even whether it's our decision making process. There's the opposites of the positive negative is always there, right? It's
Right.
like, and that's so fundamental, and it kind of manifests itself in human behavior. Like there's so I think forces and attractors and all of those things kind of human behavior can be explained using physical phenomena, and that's not I haven't seen that anywhere. Like, but maybe I just haven't searched hard enough. If anyone's really done that, so
Say that again. I didn't quite catch that. You haven't seen exactly what?
if there's any good resources out there, if anyone has attempted to explain, uh, I guess human behavior using physical phenomena, like in terms of
Ah, I see. I
yeah.
see.
So if I wanted, because
Well, my understanding of that, such as it is that there are portions of human behavior for which we have reasonably good explanations, like how strong we can be in exerting muscles. Well, that depends upon the physiology of muscle tissue and metabolism and blood flow, et cetera, et cetera. There are things like that that are reasonably well understood from a pretty basic biochemistry, biophysics perspective.
mhm.
There are other aspects of human behavior about which I think there's almost no understanding, and the more deeply an aspect of human behavior is connected with the operation of the brain and the operation of the mind, the harder it is to understand in basic physical terms.
Mm.
Um, yeah, but you mentioned I think I heard you mention attractors and uh,
Yeah, so I think one of the things I'm attempting to do is explain human behavior using forces and attractors. Like, for instance, if I'm making a decision to do something, there's always things which are opposing me
uh-huh,
making that decision, and things which are promoting
right,
me making that decision. So these are kind of opposing
yeah.
forces, and if the promoting force exceeds the opposing force, then I make that decision. So something like that.
So you weren't using the word attractors in the technical sense of chaos theory or anything or
N-
non-linear dynamics.
Not quite, not quite.
Okay.
It's more like attractors where, like if you think about, I mean, I think mathematically we can. It's different. I guess in a way, it's different to the attractors in chaos theory. It's more
Uh-huh.
about things which, like for instance, if you think about a decision as an attractor, like it's a kind of um, I'm not sure if this is the right term, but it's
Right.
kind of things which forces are going to and away from. So if you
Right.
have two
Right.
attractors, like it's kind of the two poles of a magnet in a way.
Yeah.
Uh,
Yeah. 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 Uh,
so I mean, as I'm actually writing a few things, and I would be very grateful if I can share that with you, and receive your feedback in terms of it might totally make no sense from a
tell you,
from a
tell you what. Tell you what. I'll make an agreement with you to do that if you'll be willing to accept something I might send you that I wrote.
Oh, absolutely. But I mean, I'm but again,
Yeah. Sure. No problem.
no, I'm very grateful.
And I do you have in mind like attaching something to an email
Yeah,
and
I think
sending
that
it?
that's probably
Yeah.
easiest if I can just show
Right.
you,
Right. Right.
and
We can
and,
do
and
that.
please, I mean, feel free to just let me know. That's just like, if you tell me this is just nonsense, and I'm completely fine. I just want to make sure I'm on the right track if I'm going to kind of come up with some models and theories that they
Yeah.
they, they actually
Well,
make sense.
the
Mm,
most difficult thing is to identify the right track.
mm,
I mean, there are so many tracks going on right now in so many different directions. They can't all be right,
No,
but
yeah,
it's very hard to tell which of them are closer to the right track.
exactly. It's
So
closer to
don't worry
reality.
too much about that.
I
Yeah.
appreciate that. It's again, it's very much for me things that I've been trying to make sense of in terms of explaining my own behavior and why
Hmm.
things are the way they are instead of kind of blaming the world. Why is this like the way it is?
Right.
Just
Right.
really
Yeah.
understanding. Okay, once we get a deeper understanding of phenomena, then we don't have to play a blame game or try to kind of you know have a reductionist kind of mindset of oh yeah so it's really much around coming to a point where we just relinquish this blame game because I think at the moment we're not there yet. Like if you look at
Yeah.
society, everyone's just making all this kind of right and wrong and good and bad, and that's I don't
Yeah.
think that's where we need to be. I mean, we need to kind of elevate beyond that,
Yes.
so and that's what I'm attempting to do is just to come up with something where it was like everyone looks at it as like okay now we this makes sense okay then
Right.
there's
Right. Right.
people then they can function in a much more effective way, and I think like for me that's the thing, like when I see the world like it makes a lot of sense. Like I don't at this stage, and I'm trying, and it makes sense because I have some mental models that explain behavior and explain my what I observe, and it makes sense. Like I don't have to blame or point fingers or say there's no good
Right.
or bad, or it just makes a lot of sense. But so I'm just trying to kind of put that into a framework which is both right. I mean, as much as possible, it's correct. I think it was there was a statistician who said all models are wrong, but some models are useful, and I think probably that's what we can use. But again, I want my model to
Yeah.
be
Yeah. I have. There's a certain sense in which I have a kind of sympathy for that idea that all models are wrong. But I think there's a more positive way that one can put it, and that would be to say that all models are capable of improvement.
mm,
And if they're capable of improvement, that means they can't quite be perfect already.
mm,
And if they're not perfect already, then in some sense they must be a little bit wrong. And my guess is that all of the conceptual, uh, all of the realm of concepts that we can use to try to build models, those concepts have precise structures, but the likelihood that they exactly match reality is very small.
mm,
And we're very lucky that we can get them to almost match reality to an extremely good degree, and then we can improve upon them. Never getting quite the perfect final result, but always improving, improving, improving.
absolutely.
And that's sort of the way I see that going. And it's good to keep on trying to do
Yeah,
that.
absolutely, and I
Yeah.
fully agree with that, Dr. Fleming, because I think like if we can just continually improve the models, like and the only way for that is for others to look at them and critique them, and then we just keep
Yes. Right.
refining it. And then I think that's what I'd like to do. I might present something which is not even near perfect, but then as I get
Right.
feedback, I can
Right.
refine
Yeah.
it. Yeah, so I'm very grateful for that. And
Yeah.
um,
Yeah.
yeah, and
Takes a little bit of courage to present your ideas, knowing almost perfectly that they will fall short of reality to
mm,
some extent, and somebody else will point out to you
mm,
how they have fallen short of reality.
yeah,
But you got to be willing to accept that.
absolutely. And
That's the way we learn.
that's exactly how I am. I know as soon as I share it, I
Yeah.
will get critiqued, and that's the whole point. I mean, for me, it's not about me being right. It's for me
Yeah.
to to
Right. Right.
to
Right.
build
Yeah.
something that actually is as close as possible represents what reality
Yeah.
is. Right.
Yeah. Okay. Good. I will try to think of various things that I might think would be worth your while to take a look at. Do you have any other questions you want to ask right now?
Uh, At this stage, no, but I would love to continue our conversation if you'll be
Yeah,
willing. I mean, I think it would be really great. And if it's okay, if I can share this interview with my students, would you be okay with
absolutely.
that? That would be wonderful. And no, I'm really grateful for that. I'm very grateful that I had the opportunity to meet you. And I'm glad you were kind of speaking loud enough for me to overhear the conversation. Otherwise,
I'm a little embarrassed by that.
not at all. If it wasn't for that, we won't be having this conversation right
Yeah,
now.
but I'm thinking of the poor guy who was sitting in the booth between us.
Oh well, yeah. To be honest with you, when I came in, I was thinking whether should I sit on the one right next in front of your table or the one, and then I just like said, okay, I'll just sit here. But I sense a certain energy coming from your end that I like. For me, it's like
Uh,
I need to sit close.
well, the guy that I was talking with in my booth,
Yeah.
he's a retired professor of statistics
Hmm.
who has become fascinated with the different ways in which probability is used in quantum mechanics.
Hmm.
So, on one hand, he's an expert in probability theory because he's a professor of statistics,
Mm.
but he's never seen in his domain some of the kinds of uses of probability theory that occur in quantum mechanics. So he's been learning quantum mechanics, and I've been blown away by his ambition because we've been at these discussions on Friday mornings for years,
Right.
literally years,
Uh-huh.
and he's really digging in and learning quantum mechanics. So we have a lot of fun with our Friday
That's great. I
discussions.
mean, yeah, that's wonderful.
Yeah.
Yeah. And uh,
So
and
yeah,
I and I
go
hope I
ahead.
could come again. Like there is a possibility that I'll be at State College next year around the same time in February if I have the same. So the way the program works, I take 12 students to Penn State and they sit in many of the leadership and entrepreneurship subjects
Right.
that is offered by the College of Engineering. So I may be able to meet you in person again if
Okay.
yeah.
Yeah, that'll be great.
But
Uh,
yeah,
and in the meantime, we'll just exchange some emails and maybe have another Skype session like in a week or 2 weeks or something like that.
that would be wonderful.
Uh,
Yeah.
yeah.
So if we
Okay.
can
Okay.
have, I think if we can have these regular conversations, then that would be wonderful because then we can just, talk about different ideas in physics and
Yeah.
philosophy, and
Right.
so that would be great. Yeah, wonderful. Thank you so
Okay.
much.
Very good. All
Thank you so
right.
much, Dr.
Pleasure
Fleming.
talking to you.
Pleasure. It's
Take
been a
care.
pleasure. Thank you, and have a good evening. And thank you again.
See you.
Bye for now.
Okay. Bye bye.